Hello everybody, welcome to Tech Struct Hub. We simplify the data structures and algorithms. What exactly is a data structure and how do we use it to optimize our algorithms? In this video, we will explore the fundamentals of data structures and their crucial role in improving the efficiency of algorithms. Join me as we dive deeper into the world of data structures and discover how they can transform the way we solve complex problems. What is a data structure? A data structure is a collection of values. The values can have relationship among them and can have functions applied to them. We can think of a data structure as a container of values. It helps us to organize data. It helps us to store various kinds of data like numbers, strings, booleans, etc. There are various types of data structures such as arrays, linked lists, stacks, queues, trees, graphs, hash tables, etc. They handle various operations such as storing data, searching, inserting, updating, and deleting. Each one is different in what it can do and is used for. Each data structure is good and is specialized in its own thing. Data structures are foundational to computer science because they affect the performance and efficiency of algorithms. The efficiency of an algorithm depends on the type of data structure we use. The choice of data structure can significantly impact how fast a program runs. Each data structure is designed for particular operations, whether it's fast lookup, easy insertion, or optimal memory usage, making them specialized tools for different scenarios. Now, it's time to learn our first data structures, arrays. Most of you are already familiar with arrays. Arrays, sometimes called lists, organizes items sequentially. That means one after another in the memory like we have here. At index 0 we have banana, at index 1 we have apple, at index 2 we have grapes, and so on, some sort of fruits list. In our computer's memory, they will be stored one after another. Arrays are the most simplest and most widely used data structures. If all we need is to store some data and iterate through it one by one, then arrays is the best choice of data structure. Here is a quick glance of time complexity for each operation performed on array. Let us discuss these time complexities with simple example. I have declared an array of strings here. In arrays, this index starts with 0. So apple is at index 0, banana is at index 1, cherry is at 2, and orange is at 3. Once an array is declared in computer memory, the elements of the array will be stored in sequential order. So when I do print fruits of 2, I am telling the computer to go to the memory where it stored my fruits array and grab the third item. Here in the fruits array, the third item is cherry. So it should print cherry for me. It is a lookup operation. It is a constant time operation. As we can see here, lookup is a constant time operation. Now let's look at some inbuilt methods in Python. In Python, arrays have some inbuilt methods. Now let us look at append operation. Append means we are appending to the end of the list. So I will do fruits.append peach and print the array. What happens if I do this? It is adding element peach to the end of the array. For this operation, we are not looping through the array. We are just appending to the existing array. Hence, it is a constant time operation, which is O of 1. Now, we added element at the end of the array. What if I wanted to add a desired index, like I wanted to add it at the beginning of the array? Then we can use insert method. Fruits.insert. First, we need to provide the index where we want to insert that element. I'm providing 0 because I'm adding at the beginning of the array. And then we need to provide the value we need to add. And let's print this. As we can see, grapes has been added at the beginning of the array. What could be the time complexity of this operation? In this step, as we're inserting an element at the beginning of the array, all the existing elements are being shifted by an index. Earlier, apple is at 0 index. Now, apple is at 1 index. Banana moved to 2, and so on. How many operations did it take to realign my array? It took 6 operations as we're adding new element and shifting existing 5 elements. Hence, the time complexity for this operation is O of n. It is similar for delete operation. To delete an element from array, we can use pop method. Let's say I want to delete apple. It is at index 1, so I give fruits.pop 1. And I'll print this again. What could be the time complexity of delete operation? Here we can see that apple has been deleted from the array. As you have guessed, the time complexity for this operation is also O of n. As we are deleting an element, we are shifting the remaining elements by an index. In big O, as we learned earlier, we need to consider the worst case scenario for time complexity. The worst case scenario for a delete operation is deleting element at the beginning of the array, as as that will result all the elements being shifted by one index. Hence, delete operation is also O of n. Now, let's look at types of arrays. There are two types of arrays: static array, dynamic arrays. Static arrays means they are fixed in size, meaning you need to specify the number of elements your array will hold ahead of time. In programming languages like Java and C Sharp, when we define an array, we need to specify the length of the array. Example of array declaration in C Sharp will look like this. This says I want an array with memory for 5 items. If we want to add an extra element to this array, the system needs to copy the entire array, add new element and move it to different area of memory. In Python and JavaScript, arrays work like dynamic arrays. Dynamic arrays automatically allocate memory according to the increase in size. In C Sharp, lists can be used as dynamic arrays. Dynamic arrays expands as we add more elements, just like how our fruits array expanded. If we look at the time complexity chart of array again, we can see that append can be O of n. This is because in a dynamic array, when an array is defined, a memory will be allocated for that array. When initial assigned memory reaches its maximum capacity and we want to add a new element to the array, the system typically doubles the size of the array to optimize memory usage and reduces number of resizing operations. Let us consider our example. In this example, I have defined an array with 4 elements. Hence, the memory allocated for this array is 4 into 4, that is 16 bytes. When we add a new element to this array, then this array's memory allocation will be increased to 32 bytes, which is double of 16 bytes, allowing us to add 4 more elements to the array. During this resizing operation, all our existing array elements will be looped over and copied to new array. Hence, as we are looping through the elements to copy to the new array, the time complexity will be O of n. Hence, although the append operation can be O of 1, it could be O of n sometimes. Now that we know how to use arrays, where they are fast, where they are slow, let us build arrays from scratch. This will not be asked in interviews, but doing this exercise will lay a good foundation for us. Many data structures are built and being used in different programming languages, but we can always build our own data structure. Let us build our own array class. I'm calling it my array. I have defined some initial methods like initialization, where I'm assigning the capacity to 0 and uh, the number of elements in the array right now is 0 and capacity is 1, and I'm just making some array for data, and I have this resize method and I have this make array, and I have this length where I just return what number of elements right now in the array. Now if I print this one, it is giving me length is 0. Okay, now let's start with append operation. For this I will define append method. So as we are passing the element here to append, I am using k for that. First let's check if our array is at capacity. Then I'm calling the resize method, so that as we have discussed earlier, dynamic arrays will be resized with double the capacity. Okay, now I'm assigning the value right now here, and I'm incrementing the number of elements in the array. For our testing purpose, let us return the element we have just added. As we incremented the self.n, I need to do -1 so that I can get the last element. Now let us call this method. I am printing array dot append. Let's say I will append 3 and again print the length here. Let us run this. We can see the element that has been appended is 3 and the length is 1 right now. Let us try to append a couple of more elements here. Let us say 3, 2, 8. I'm giving randomly 5. As we have, as we can see, there are 4 append operations and my length of the array is 4. Now let's try to get an element at particular index like how we did fruits of 2. Let us try to do that here. For that, let us define an method again, get item, maybe get operation. So I'll do self. I'm giving the index here, so let us say index. Before actually loading element at that index, we need to check whether the index is valid or not. So I'm doing if not, I'm returning some index error now here. If not, I'm retrieving that element. I'm returning that element here. Self dot data of that index we are getting. Let's try to element. Let us try to get an element at index 2. As we can see, it is giving us the element at index 2 is 8, 0, 1, 2, 8 is the right answer. We can try to delete as well. Similarly, let's try to delete it. Let us define that method as pop. I'm just trying to delete from the end of the array right now. So if there are no elements in the array, then I'll give that error. And I'm printing the element that we are deleting here. And I'm reducing the number of elements. Okay, let's call this array.pop and let us print the length again. I'm expecting the length should be 3 once we run this at the end. We can see that we're deleting the element 5 and the length is 3 now because 5 is the last element and that has been deleted. Like this, we can implement our own data structure. That wraps up our discussion on arrays and how they are implemented. Now that you understand the fundamentals, it's time to put that knowledge into practice. In the next video, we will dive into solving some lead code problems on arrays, so stay tuned and get ready to learn up your problem solving skills. Thanks for watching. If you're finding the content helpful, don't forget to give it a thumbs up and hit that subscribe button and click on the bell icon to get the notification as we upload the video. It really helps the channel and you'll stay updated with all the upcoming videos. If you have any questions, please post them in the comment section or you can send them to the email directly. Keep practicing and stay tuned for more problem solving sessions ahead. Until then, this is Yes signing off. See you in the next one.